Hello. So I come back to 5G in my talk and want to speak about value creation or value propositions of 5G technology. I think being here in Greek, Athens, is a good, or maybe the best place to speak about history. So the GSM journey started for me 30 years ago, 1988, with digital voice, 900 megahertz, a pan-European standard. We have to admit that we tried to do data on GSM with GPRS and Edge, not very successful. At the turn of the century, new generation, the third generation, UMTS, a universal system. That means we could use it now also in Japan, for instance. And we had data, but a very sophisticated brand of data. And it did not really fly. We started with dedicated channels, the shared channels. And with LTE, the fourth generation, data on mobile networks become more successful. So we can ask ourselves why. I said it was complicated, but it was also that operators locked their business model in their own proprietary portals, and WAP was not very efficient neither. So LTE, we can discuss whether it was the technology or whether it was the smartphones, the user experience, but both together gave a very simple and plain access to the network. And we replicated the internet business model, which is mainly based on best effort and net neutrality, to the benefit of the internet giants like Facebook, Google, Amazon, to name a few. This is now going to change with 5G. Maybe one reason why these guys don't like it so much, but we will have new business models based on guaranteed services, low latency. I've got a few of them, and I will talk about them in more detail later. A short look on the network. So I'm a radio guy, but it seems that the real value of 5G is in the core network, in a sliced architecture. And I will explain it a little bit. So the capability to deliver a service for a group of users is the key capability of sliced networks. Let's look on the automotive case. So you don't want to interfere with any kind of security or safety application because you do an upgrade on your infotainment system. So basically, on the same network, you have different networks. And this is done by network virtualization on the one side, and on the separation of user plane, control plane, or for other people, payload and signaling. So just a scope on the automotive case. So the infotainment is a typical cloud kind of service. Most people will agree that for ADAS kind of systems, you would have good digital maps, accurate digital maps. And this kind of information you don't want to have too far away from the car. It's a rather regional information. So that is a typical application you will find in a regional situation, probably implemented on a mobile edge platform. And then you have got more security things which are within the radio. So the network is distributed and hierarchical in that way. In GSM, the enabler was 900 megahertz, been available over all Europe. 2.1 for UMTS, 2.6 for LTE. Now the C-band is the major band for 5G. And this is a moving picture. Some auctions are delayed, some getting earlier. I understand that the 3.5 gigahertz band in Greece will be auctioned next year and ready for deployment in 2020. If we look in past auctions, we see different trends. And for instance, in UK with Ofcom, we have a situation where we have coexistence with an existing fixed wireless access player which is in the frequency band, and we have the problem of having coexistence of broadband operations. And then in Germany and Sweden, we have got a very interesting trend where we have a part of the frequencies reserved for industrial and regional operations, and also a requirement for road coverage. On the outside, you will see a lot of use cases about virtual reality and this kind of applications. In the sake of time, I will move a little bit faster over that. Another use case we have been speaking about is the fixed wireless access. That means we have got still a lot of white spaces, and it's a much cheaper, more efficient and faster way instead of digging for fibers. And this has been mentioned, and North America is certainly the most prominent case where we have it. And here is one of my favorites, which is the connected car. Some people are considering the connected car as a smartphone on wheels. So we see a nice trial we have been doing. So we have got a car is fully controlled over a 5G network by a person which is sitting 50 kilometers away. So we have here two key parameters or characteristics of 5G, which is low latency and high data rate for the cameras. Huawei has been, or is a founding member of 5GA, the 5G Automotive Association, and this is due to the fact that automotive industry and telecommunication industry have different cultures, different terms, and we need to understand the different business models. You change your mobile maybe every 18 months, but you don't change your car as often. It takes about 18 months to make a new release in 3GPP. It takes about 7 years to make a new car platform. So there is a lot of cultural work to be done to make it successful. And there is one question, which is how to make money out of that. Because we have got requirements which are about safety on the one side, and it's very popular in politics. But the question then is, if you look on a BMW or an Audi, how can you sell additional feature on this 80 or 60, 80,000 euro car? And we come to the point that a lot of the safety things is car-to-car communication, and the commercial features are mainly on the car-to-network communications. So that means the safety is in the 5.9 ITS band, and the commercial is on the C band. I skip this one because I'm just running out of time. So the second biggest use case is the industry application. And we have shown this at the Mobile World Conference, so 2 robots. Each of these robots has its dedicated 5G link, and we demonstrate latency, because otherwise the thing would fall down. So we have done cases like in robots within a factory, and we have got also cases of a harbor, which I will talk later a little bit. The key challenge here is, so far, the network within a factory is owned by the factory manager, by the company. Why would she go to a mobile network operators? Today they are using shared spectrum why would they use now a licensed spectrum? One way of looking on it. The other way of looking on it is on the lower side. So we have maybe a private network in the manufacturing space. Then we have got, within this manufacturing environment, wireline, of course. Wireless 5G is not replacing everything. We go into time-sensitive networks, but wireless is playing its game whenever we have got robots, tools, or things moving around. Moving around brings us to the next step. We have got goods coming in and out of the factory. So then we have got the global roaming capabilities of wireless networks which play a role. And this altogether is a solution a mobile network operator has to offer to the players here, and it's naturally based on a sliced architecture. So I would have liked to have an example for Piraeus. Here I've got a recent example from the Rotterdam harbor, where Huawei is playing together with some major players in this field. So we have got KBN, Shell, ABB, X-Robotics, Accenture, which are also here outside. So it's not about containers in this context. It is about pipelines. Rotterdam is one of the biggest ports for petrol industry. So it's 160,000 kilometers. And we can here play very interesting set of different applications of 5G. So we have a lot of sensors to control it. And it's typically a use case of connecting sensors by wireless, cheaper and flexible than with cable. We have got high definition cameras surviving, and we have got robots again for mobile inspection. And the next step would be then using the VR, AR capabilities for maintenance. So we could even do the maintenance before the equipment is in place. So I speeded up a little bit in the end, but I think I'm in time now. Thank you.